Hey mathematicians, here are your notes for 4.1 and 4.2. So we're going to be talking about a little bit of introduction and then addition and subtraction of matrices. So I'm going to read some of this, not all of this, but there's some key elements and terms that I want you to know. So a matrix, singular, is a system of rows and columns that is often used as a problem-solving tool. Each value in the matrix is called an element. So if you see your matrix right here, each of these numbers is going to be an element. Matrices, plural, are usually named by an uppercase letter, seen right here. Matrices can also be named by using the matrix dimensions with the letter name. The dimensions tell how many rows and columns in that order are in the matrix. The matrix at right would be named A 2 by 3 since it has two rows. Rows go across and columns go up and down. Think of the Colosseum, those nice tall standing columns. Matrices have special algebraic rules. For example, you can multiply any matrix by a constant, and this is called scalar multiplication. So you can see in this box, we've got some scalar multiplication going on. If k is our scalar, and it is outside, we're just going to multiply each element inside of the matrix by that scalar. Two matrices are considered equal if they have the same dimensions and each element of one matrix is equal to the corresponding element of the other. So if you see a problem like this, solve 5x plus 4 equals y over 10. Since the matrices are equal, the corresponding elements are equal, and you can see how we set that up. This goes through the rest of that explanation, but basically what it says is that we are going to be solving a system of equations once we have set the elements equal to each other. So let's jump a little lower. Let's perform the indicated operations in these examples. The first one is scalar multiplication. We have -3 times the matrix. Remember, if you start out as a 1 by 3 matrix, you have to end as a 1 by 3 matrix. So this one started out with 3 elements. -3 times 6 is going to be -18. -3 times 8 is going to be -24. -3 times 10 is going to be -30. And that is our resulting matrix. Same thing here. We've got a scalar. We now have a 2 by 3. So my resulting matrix needs to be a 2 by 3 matrix. 5 times 0, 5 times 1, 5 times -6, 5 times -8, 5 times 4, 5 times 7. Just each term individually. Next up, we have two matrices that are the same size, so we're going to set them equal. Whatever is in the first position in the first matrix, we set equal to the first position in the second matrix. 6x equals 3, and 2y equals 2. X equals 1/2, y equals 1. And we have solved that one. They may not always be so easy. This was really nice. We had variables that equal numbers. However, as you'll see in this next one, we might have to do a little bit more. So in this one, 2x equals 40 plus 2y, and y equals 5 minus 4x. We need to solve this system of equations. The easiest way in my mind is substitution, so I'm going to go ahead and do a few of those steps. 2x equals 40 plus 2. I'm going to substitute y. I get 2x, 40 plus 10 minus 8x. When I simplify, I find that x equals 5. And then, of course, just as we did before when we were solving systems, we're going to plug that back into one of our original equations so that we find y is -15. So if you're feeling a little uncomfy with the fact that solving systems of equations is coming back, come chat with me. Let's talk about that and get you really confident so that when we see that instance in matrices, we're ready to go. All right, let's see another one. 3x equals 28 plus 4y. Again, first position equals first position, and second position equals second position. Substitute. I'm going to leave that math to you. This is not the systems of equations unit, so I'm going to go ahead and solve, and I'm going to get x equals 4/3 and y equals -6. If you have questions on that problem or how I did that, don't hesitate to ask. I would be happy to go through that with you at a different time. Next up is adding and subtracting matrices. So in order to add or subtract these, they must have the same dimensions. So if A and B are two m by n matrices, then A plus B is an m by n matrix, where each element is the sum of the corresponding elements of A and B. Big fancy term for if you start out with a 2 by 2, you add a 2 by 2, you end up with a 2 by 2 where we just add each element. Same thing with subtraction. So let's get to some examples. Perform the indicated operations. We've got, this one's already done for us. Notice 8 plus 4 in the first position of these two becomes the first position here. -2 plus 1 becomes -1 up here, and so on and so forth. All right, you've got two examples to look at. If you want to go ahead and pause the video right now and try these on your own, I would highly suggest you do that. If you're not quite ready, let's go through one together. All right, first up, we've got 10 plus -2. I noticed this is a 2 by 2 to start out with, so I'm going to give myself a 2 by 2 to end with. 10 plus -2, +8. -3 plus -12, -15. 5 plus 20, 25. And 8 plus 22, 30. Let's do another one here. 2 by 2, 2 by 2. This one is subtraction. The big thing with subtraction, we have to be careful if we have double negatives. Those can trip us up. 3 minus 1 is 2. -2 minus 1 is -3. 1 minus -5 is 6. And 2 minus -6 is 8. All right, if you didn't already, go through and pause this video. Try the next three on your own. All right, let's finish it up. I've got a 2 by 3 and a 2 by 3. My end result's going to be a 2 by 3. 5 minus 1 is 4. -4 minus 4 is -8. 35 minus -35 is +70. 2 minus -2 is 4. -2 minus 2 is -4. And 16 minus 0 is 16. When we first start out our matrix unit, I always find that kids are a little bit concerned. They're a little bit nervous. Everything looks very intimidating. However, once you see that adding and subtracting isn't that hard, you realize that the worst part about this unit is the fact that you don't have as strong of addition subtraction skills as you thought you did. Don't rely on the calculator. Just be careful. Make sure you're double checking your work each time. I still mess these up, and I'm a math teacher, so make sure you're checking yourself. This one, we've got scalar multiplication as well as subtraction going on. So I'm going to go ahead and do that scalar multiplication first. Scalar multiplication of the first one is 3, 9, -6, 3, minus, I'm only going to multiply the 2 and I'm not going to multiply the negative in. I could, and then I could add the matrices if that made me more comfortable. 2, 2, -10, -12. And now that I've got that scalar multiplication out of the way, I'm going to jump to subtraction. Still going to be a 2 by 2. 3 minus 2 is 1. 9 minus 2 is 7. -6 minus -10 is 4. 3 minus -12 is 15. All right, in this last one, we've got addition inside, scalar multiplication on the outside. I'm going to go ahead and do that inside parentheses first. 2 by 2. 9 plus 3 is 12. 1 plus -5 is -4. Negative 7 plus 1 is negative 6, 0 plus 7, and now we multiply each one by the 1/4. Still going to be a 2 by 2. Notice addition, subtraction, scalar multiplication do not change the size of my matrix, so I should not see any of that on your homework or quizzes. Negative 1, 1/4 times negative 6 is negative 6 over 4, or negative 3/2, and positive 7/4. There you have it, scalar multiplication and matrix addition, subtraction. If you have any questions, don't hesitate to let me know.